Hello students, today we are going to continue with the second chapter of your textbook. The topic of the day is Venn diagrams. You must have already completed the previous assignments for this unit. The answer key of exercise 2A is provided in the PDF file attached with today's assignment. So kindly cross-check your answers, and if you have any query or doubt related to any of the question, do discuss it in the Google Classroom created for class 8. So let us start with the topic. The topic is Venn diagrams. Now Venn diagram is a closed geometrical figure which is used to represent a set or a combination of sets within a given universal set. Remember, universal set is the largest set possible for a given problem. Points within such a closed figure denote the elements of the set. The universal set is represented by a rectangle, and all the other sets are represented by circles or oval shapes inside the rectangle. The operation on sets can be represented using a Venn diagram. Not only this, we can also represent the relationship between the given sets. So here on the screen we have three different categories. The first one is overlapping sets. So see the diagram in front of it. It is a rectangle which shows the universal set, and inside it we have two sets, set A and set B, each represented by a circle, and they have a common part in between. That common part is actually the intersection. Moving on to the disjoint sets, as the definition says, disjoint sets are the sets which have nothing in common between them. So we have set A, set B, represented by two separate circles within the rectangle. And the third category is a proper subset. A proper subset is a set which is contained in another set, and that other set contains more elements than the contained set. So B is the one which is contained in set A, and A contains more elements than B. So B is actually an inner circle which is shown in the diagram. So the third diagram represents B as a proper subset of A. We move on to the representation of sets using Venn diagrams now. First of all, we are going to represent set A. In the case of overlapping sets, if you see in the diagram, we have the circle of A colored. Rest everything is not colored. So this colored part is actually set A. In disjoint sets again, you will see that the circle for A is colored. Rest everything is not having any color. And then in the third category, because it is set A, so we have set A colored along with B because B is completely contained in A. So this is how we represent set A in these three categories. Moving on to the representation of set B in the same way. In the overlapping sets, you have the circle of B colored. In disjoint sets, again the circle of B is colored. And in the third category, if you see, the inner circle is colored. We have not colored A this time because we are only talking about set B, and set B is contained inside set A. So only the inner circle will be colored this time. The next category is A union B. So let us represent it using Venn diagram. In the case of overlapping sets, if you see, both the circles are colored, including the common part. So only the circles are colored, rest of the rectangle is not colored because we are only representing A union B. In the second category, the disjoint sets, only the two circles are again colored and the rectangle is not having any color in it because we are only talking about all the elements of A and B, that means A union B. Similarly, in the third one, we have A completely colored with B inside it. So again, all the elements of A and B will be taken together. Rest of the rectangle is not having the same color. So this is A union B. Moving ahead with A intersection B. Intersection means the common elements between this set. So in the first diagram, that means for overlapping sets, the common part between A and B has been colored. Rest everything is not colored with the same color. The second diagram, that is disjoint sets, nothing is colored because there is nothing common between A and B. I believe you understand this. And in the third category, where B is a proper subset of A, only B is colored because that is the only thing common between B and A. Moving ahead with the difference set, that is A minus B. So A minus B means all the elements of A which are not a part of set B. So if you see the diagram in overlapping sets, we have only colored the part of A which is not contained in B. So that is A minus B. In the case of disjoint set, because there is nothing common, so complete circle A will be colored. In the third category, where B is a proper subset of A, we are going to exclude B. Only the part of the outer circle outside the inner circle will be colored. Rest everything will not be colored. So this is the representation of A minus B. Similarly, moving ahead with B minus A, in overlapping sets, you can see that a part of B is colored, which is excluding the part which is there in A as common thing. In the case of disjoint sets, the complete circle B is colored. But in the case of B as a proper subset of A, nothing is colored because you cannot exclude anything from A because B is completely contained in A. So nothing is colored. So this is how we represent B minus A. Next category is the complement of A union B. Remember, complement means universal set minus the given set. So in the case of overlapping set, both the circles are excluded and the rest of the rectangle is colored. In the case of disjoint sets, again both the circles are excluded, and in the case of proper subset also the circles are excluded and the complete rectangle which is universal set is colored, excluding these two sets, that is set A and set B. Then we move ahead with the complement of A intersection B. So we are going to exclude the common part and rest everything will be colored. So you can see it in the overlapping set. In the case of disjoint set, there is nothing common, so everything is colored, and in the case of proper subset, the common part is excluded. Now the next thing that we are going to discuss is another important part of this exercise. We are going to talk about cardinal properties of sets. Before we talk about cardinal properties, you should try to remember what we have discussed in the previous exercise. We did discuss about the cardinal number. So here when we are talking about these properties, we are going to deal with the cardinal number of the given sets. Cardinal number is the number of elements present in a set. So let us start with the first property. The first property is that the cardinal number of A added to the cardinal number of complement of A will give the cardinal number of universal set. That means if I am going to add the elements of A and the elements of A complement together, I am going to get all the elements of universal set. Let us understand it with the help of a Venn diagram. See, the first diagram that I have is the representation of set A. So this is cardinal number of A. Next, this is how I am going to represent A complement, because excluding A, everything has been colored. Now if you join both the diagrams together, the colored part I want you to focus upon, what will we get? We will get the complete universal set. So this proves the first cardinal property. Moving ahead with the second one. The second cardinal property says the cardinal number of A union B is equal to the cardinal number of A added to the cardinal number of B, excluding the cardinal number of A intersection B. That means I am going to add both the sets and the common part will be excluded. Let us see the thing with the help of Venn diagram. So the first diagram that you see is the representation of A union B. Both the circles are colored if you see it carefully. Next, we have the representation of set A. This will be added to the representation of set B. But remember, both of them are having the common part. So we have to exclude the common part from one of these two. So this is what we are going to do. We are going to subtract, we are going to exclude the common part once. So what will we get? We will get the union of both the sets. Moving ahead with the third cardinal property that says the cardinal number of A union B is equal to the cardinal number of A minus B plus the cardinal number of B. That means whatever is there in set A excluding B has been added to set B. So in total what do we have? We have the complete union. Let us understand it with the Venn diagram. This is the representation of the union of both the sets. This is the difference set A minus B. I'm going to add n B to it. That means the set B to it. If you see, if I am going to combine the colors on the right side, what will we get? We will get both the circles colored. So this is how it proves the third cardinal property. Moving ahead. The fourth property says that the cardinal number of A minus the cardinal number of A minus B should be equal to the cardinal number of A intersection B. So let us see it with the Venn diagram. The representation of set A minus the representation of A minus B. So if I am going to exclude this part from set A, the colored part, the second diagram, if I exclude it from the first one, what will we get? we will get only the common part. So this proves the fourth property. Moving on to the final one, that is the cardinal number of a minus b added to the cardinal number of b minus a added to the cardinal number of a intersection b should give us a union b. Let us see it with the diagram. The representation of a minus b added to the representation of b minus a. See the colors carefully. Added to the a intersection b. So if you see all the colors combined together, what will we get? We will get the complete circle's color, that is A union B. So this is how we prove the fifth cardinal properties. So students, these five properties are very important and you need to use them in this exercise. Go through them in the given PDF also. I believe you will be able to understand them, and then you have to remember them also in order to solve the exercise. So let us proceed further. Now for those of you who have already purchased the textbook, do go through the solved examples given before you attempt the exercise. And for others, I am hereby providing the image of the exercise to be done as your next assignment. So the next exercise to be done is the last exercise of this current unit, that is exercise 2B. So we have 6 questions here and more questions in the second slide. So in total we have 13 questions. So see them carefully. We are starting from question number 1 going till question number 13. So in total there are 13 questions. I'm going to explain a few of the questions to you, but then the limited number of questions are to be done in the notebook this time. I don't want you to do all the 13 questions in the fair notebook. So there will be limited number of questions which I am going to tell towards the end of this explanation. So let us proceed further. We are going to talk about one more thing before we start with the exercise, that is how to represent three sets together. Till now we have talked about two of the sets taken together within the universal set, within the rectangle. But this time I am going to talk about three different sets taken together. Why so? Because the starting few questions in the exercise contain the questions based upon three sets. So let us see the representation now. So what do we have? We have a rectangle which is representing the universal set. And then we have three sets. If you see three circles A, B and C with common parts in them. So whatever is there in between A and B is actually A intersection B. Whatever is there between A and C as common, it is A intersection C. And similarly, whatever is common between B and C, it is B intersection C. But then there is a part in this diagram which is common to all the three, that is A, B and C at the same time. So what do we call it? We call it as A intersection B intersection C. So you have to be very sure about this diagram, and in case you have any sort of query, you can always let me know in the Google Classroom. So let us proceed further and we start with the discussion of the exercise questions. Okay, question number 1. The universal set is given to us ranging from 0 to 9. Set A is equal to 1, 2, 4, 6, 8. B is equal to 2, 3, 5, 8 and C is equal to 2, 5, 6, 7. So in this question we have the universal set and we have three more sets. So let's see what is it. First of all, we are going to draw a Venn diagram for it. Remember what we have discussed just prior to this slide. We have discussed the representation of three sets with the help of a Venn diagram. So that is the concept which I have used. The rectangle represents the universal set here. Then we have the set A which has all the elements in it. Now, before we plot the elements within the circles, you need to take care of the common things. That means what is common between A and B. So what is common in between A and B? If you see 2 is common and 8 is common. But at the same time, you need to see set C also, because there is one part of the diagram which is common to all the three. So in set C, if you see 2 is there, so that means 2 is there in all the three, that is A, B and C. So that's why in this part of the Venn diagram where the common between all the three is written, I have written 2. Then the remaining element which was common between A and B, that was 8, I have written in the part which was left, that is A intersection B. A intersection B actually contains 2 and 8 both, but 8 is there as a part of this component and 2 is there where all the three circles are meeting. Fine. Similarly, what is common between A and C now? It is 2 and 6. So 2 is already written, 6 I will write in this part. Similarly, B and C, 2 I have already written. The other thing common is 5, so I will write 5 here. The remaining elements of each set will be written. Now there will be few elements in the universal set which are not there in either A, B or C. For example, 0 and 9 are not there anywhere in all the three sets. So 0 and 9 therefore are written outside the circles but within the rectangle. So let us continue with it. Okay, so in the first part, we have to find A intersection B, which is going to be 2 and 8. You can clearly see it in the Venn diagram. The fourth part is to find A union B. That means all the elements which are there in A and B together. So it is 1, 2, 3, 4, 5, 6, 8 as the answer. The seventh part, to find the complement of A, that means everything which is outside the circle of A. That means whatever is there in the circle of A will not be included as the answer. So rest everything will be written. So the answer is 0, 3, 5, 7, 9. The next part is part number 12, which I have picked up. It is the complement of A union B. That means I'm going to see both the circles A and B together, and whatever is outside the scope of these two circles will be included as the answer. So the answer would be 0, 7, 9. So this is how it becomes very easy to pick up the elements for the required set once your Venn diagram is ready to go. Moving ahead. Question number 2 and 3 are very similar. So let us discuss question number 3 so that you can attempt the second question yourself. Question number 3 has a Venn diagram already given. In this Venn diagram, again we have the representation of three sets which are P, Q and R, and the elements are mentioned within the rectangle which represents the universal set. Okay, the first thing asked is universal set. Seeing the elements in the given diagram, we have all the letters of alphabet ranging from A to R. So the answer will be A, B, C, D, E, so on till R. The second part is to find P. P means all the elements which are there in the circle of P. So it is F, G, H, J, M, P. The third part is the elements of Q. That means all the elements written in the circle of Q. So the answer is A, B, C, D, E, F, G, I, N. The fourth part is to find the elements of R. So elements written in the circle of R, G, H, I, K, L, N is the answer. Seventh part is the complement of R. So complement of R means whatever is beyond the scope of the circle of R will be taken. Means whatever is there inside the circle of R will be ignored. Rest every element will be taken. So the answer would be A, B, C, D, E, F, J, M, O, P, Q, R. Moving ahead, the ninth part is the intersection of Q and R. So whatever is common between Q and R will be taken. So see in the diagram between Q and R we have three elements in common. So the answer will be G, I, N. The 12th part is a difference set, that is P minus R. Means all the elements of P which are not there in R. So the elements will be J, F, M, P. In any order you can write it. So suggested is that you write it in ascending order. So the elements are F, J, M, P. Now question number 4 and 5 are also similar. Let us discuss question number 5. In question number 5, A minus B is given as 1378. B minus A is given, that is 246, and the intersection of A and B is given, that is 5. So that means these two sets A and B are actually overlapping sets and they have 5 as the common element. So the first thing I have done is I have drawn a Venn diagram because it becomes easy to get the answer once your Venn diagram is clear. So there is a rectangle representing universal set and we have two sets A and B with a common part as the part of this rectangle. So 5 is the common thing, so I have written 5 first in the common part of these two circles, and the remaining things, that is A minus B is 1378 and B minus A is 246. So writing the elements as it is. Okay, the first part is to find the elements of A. So everything will be included, whatever is there within the circle of A in the Venn diagram. So it will be 13578. Set B will be equal to 2, 4, 5, 6. Remember the common part will be included. The third part is A union B. We are going to pick up all the elements from both the sets, including the common one. 1, 2, 3, 4, 5, 6, 7, 8. No repetition is allowed. Moving ahead with question number 6. I have picked up the second part of question number 6, that is B part. Here the cardinal number of P is given as 50, the cardinal number of Q is given as 30, the cardinal number of P union Q is given as 70. So three things are given and we have been asked to find the cardinal number of P intersection Q. So I have assumed it to be X. Remember, here comes the use of cardinal properties that we have gone through. So I'm going to use the property. The cardinal property is the cardinal number of A union B is equal to the cardinal number of A plus the cardinal number of B minus the cardinal number of A intersection B. Let us substitute the values. We have A union B equal to 70, the cardinal number. The cardinal number of A was 50, the cardinal number of B was 30, and A intersection B cardinal number we have assumed as X. So we get an equation, and once we solve it, we get X is equal to 10. Therefore, the value of cardinal number of P intersection Q is 10. Moving ahead, 7, 8, 9. These three questions are very similar. So let us discuss one of them, that is question number 8. In question number 8, again the cardinal numbers are given. The cardinal number of universal set is 25, the cardinal number of A is 17, the cardinal number of B is 7, and the cardinal number of the complement of A union B is given, that is 2. So we are going to do the first part, that is to find the cardinal number of A complement. So let us assume it to be X. We are going to use one of the cardinal property, that is the sum of cardinal number of A and the cardinal number of A complement should be equal to cardinal number of universal set. Once you are picking up the cardinal property, see to it only one value should be missing in the property. Rest all the values should be given. Then only you can get the missing value. Okay. Substituting the values here and getting an equation, you will find the value of X equal to 8. Therefore, the cardinal number of A complement is equal to 8. The second part of the same question, we have to find the cardinal number of B complement. The cardinal number of complement of B we have to find. So we have assumed it to be X again. Using the same property one more time, we are going to substitute the values, and this time the value of X comes equal to 18. Therefore, the cardinal number of complement of B is equal to 18. The third part is to find the cardinal number of A union B. Again, assuming it to be X, and this time using the property again, because the cardinal number of the complement of A union B is given, so we can very well use the same property one more time. This time the equation will be this, and the value of X will be 23. Therefore, the cardinal number of A union B comes equal to 23. Moving ahead with the fourth part, where we have to find A intersection B, the cardinal number of it. So assuming it to be X, this time the property that I am going to use is the cardinal number of A union B equal to the cardinal number of A plus cardinal number of B minus cardinal number of A intersection B. Substituting the values here and getting the value of X, it comes equal to 1. So cardinal number of A intersection B comes equal to 1. Moving on to the fifth part of this question, where we have to find the cardinal number of A minus B. So assuming it to be X and using the property cardinal number of A union B equal to the cardinal number of A minus B plus the cardinal number of B. Substituting the values, getting an equation and solving it for the value of X, the value of X comes equal to 16, and therefore the cardinal number of A minus B is equal to 16. Moving ahead, we have the sixth part also, where we have to find the cardinal number of B minus A. Assume it to be X and using another property from the cardinal properties, that is cardinal number of A minus B plus cardinal number of B minus A plus cardinal number of A intersection B should be equal to cardinal number of A union B. Substituting the known values and the unknown value as X. So 16 plus X plus 1 equal to 23 is what we get. Finding the value of X, the value of X comes equal to 6. And hence the cardinal number of B minus A is equal to 6. Similarly, the other two questions, that is question number 7 and question number 9, are based upon the same concept, wherein you have to pick up the cardinal properties from the 5 properties that we have discussed earlier in this presentation. Okay. Now question number 10 and 11 are very similar, so I am going to discuss question number 11. In question number 11, the cardinal number of universal set is given as 100. The total number of students in the class will be taken as the universal set, so it is 100. Then the total number of students who take English, who like English, are 60. So I have taken the cardinal number of English as a set E equal to 60. The students who like Hindi, the number is given as 80. So I have taken the set Hindi as H. So cardinal number of H is equal to 80. Now what we have to find is that how many of them are liking both the subject, that means English as well as Hindi. So what we have to actually find is the cardinal number of E intersection H. So I have assumed it to be X. Drawing the Venn diagram for it first. So we have a rectangle which is representing the universal set. In between the rectangle we have two sets, and yes, there will be common students who are going to like both the subjects. So I have taken the sets to be E and H respectively. I have assumed the common part to be X. So who are the students who only like English? It will be the total number of students who like English minus the common. So it will be 60 minus X. Similarly, the students who only like Hindi will be 80 minus X. The common thing will be subtracted. Now using this concept, I am going to proceed further. One more thing to be noticed in this question is that the students in the question, it is given that they either like English or Hindi or both. That means here the universal set is actually equal to the union of both the sets. There's nothing else left in the universal set. So the union of both the sets is actually equal to the universal set. All the elements are there equal to the elements of universal set. Okay, so we are going to use the property cardinal number of A union B is equal to cardinal number of A plus cardinal number of B minus cardinal number of A intersection B. Substituting the values in here, we have 100 because A union B is nothing but the universal set here, equal to 60 plus 80 minus X. And once we are going to do that, we are going to get the value of X equal to 40. So in total 40 students are there who like both English and Hindi. This is how you have to solve question number 10 also. Moving ahead, we have another question picked up, though I'm not going to solve it completely because I want you all to attempt it, but still I'm going to give you a bit of hint, and this hint is actually going to give you the ease of solving this question. Okay, the question says that out of a group of 1000 people, 560 have television, 250 have computer, and 130 have both. We have to find the number of people who have only a TV. Remember, only a TV means if we take the set to be T and C respectively as TV and computer, only a TV means T minus C. That means only the elements of television which are not there for the people who like computers. Okay, who have computers, fine. So T minus C is what we are talking about. Only a computer similarly will be the cardinal number of C minus T, means the people who have computers, not television. So the set of television will be excluded out of it. Either a TV or a computer or both. In the previous question we had a discussion about it. That means the union of both the sets. So we have to find the cardinal number of T union C. Now neither a TV nor a computer, that means the complement of union. So we have to find the cardinal number of complement of T union C. So this is what we have to do in this question. Fine. What I'm going to provide you is the Venn diagram related to the question. See if you can understand it. Okay, so I have made a rectangle representing the universal set. Within the universal set, I have taken two sets represented by T and C. T for television, C for computer. There were 130 people who have both television as well as computer. So I have written the common thing first. Now, only television means out of the people who have television, I am going to subtract the common. So that is 560 minus 130. That is common number of people. So the result will be 430. Hence 430 people have only television. Similarly for computers, if I have to find the people who have only computers, I am going to subtract the common thing out of it. Total count was 250. I am going to subtract 130 from it. So I am going to have 120 as the answer for the people who have only computers. Now the thing is to find the union of it. So I'm going to add all the three results now. That means only television plus only computer plus the common thing. So 430 plus 130 plus 120 is going to give you 680 as the result. And if I have to find neither a TV nor a computer, that means I have to find the complement of A union B. So I'm going to subtract the total union from the universal set, the cardinal number of universal set. So it will be 1000 minus 680. That is going to give you 320 as the answer. So this is how you have to complete question number 12. Now this is just a hint given to you. You have to write it with proper statements and you have to solve it properly in the notebook. So we move ahead once this explanation is done. And your assignment for the week is what we need to discuss now. So after this explanation, I proceed further with the actual assignment for this week. Remember, you need to attempt exercise 2B in the same fair register in which you have completed your previous work. Questions to be done in the notebook are, remember, only these few questions are to be done in the notebook. Do not do all the 13 questions. Only do the mentioned questions which are given. So question number 1 has to be done, question number 4, question number 6, 7, 9, 10 and 12. So if you count them, there are in total 7 questions which are to be done in the fair notebook. The rest of the questions can be attempted in the book with a pencil, or you can do them in some rough notebook. So kindly do only these 7 mentioned questions in the fair notebook. Until we meet next time, students, take care of yourself, stay safe. Thank you.